Hello, welcome to today's webinar about the University of Washington Department of Biostatistics Capstone Thesis Program. My name is Hitana Garofalo, and I serve as the Graduate Student Advisor for the Department of Biostatistics. And before we begin, I wanted to review a few housekeeping items with you. First, we are recording this webinar and will send you an email later today that includes a link to the recording as well as contact and other information. Also, if you have questions throughout the presentation, please submit them via the question icon on your control panel. We will get to as many questions as we can during the Q&A at the end of today's presentation. If we don't get to your question, or if your question is specific to your situation, we will follow up with you individually after the webinar. So again, my name is Hitana, and presenting with me today is Professor Adam Spiro. So here you see the agenda of what we're going to be going through, talking about the field of biostatistics, the UW Biostatistics program in particular, the Master of Science Capstone, both the overview and the curriculum, the UW campus and Seattle area to tell you a little bit about where we are, graduate employment, admissions information, and then questions. So why biostatistics? It's a field that unlocks the puzzles of big data, and it uses cutting-edge statistical tools and methodologies to do that. It improves the health of individuals and communities, and it's a field with growing demand. Why UW Biostatistics? The UW Biostatistics program is #1 ranked program. Our goal is to help you become a groundbreaking thinker and an innovator in the field. The UW ranks among the top university recipients of federal research funds, internationally recognized faculty with real-world research areas crucial to medicine, to big data, and new statistical methods. Collaborative working relationships are also a hallmark of our department. And why the Master of Science Capstone? Adam, I think at this point I'm going to turn it over to you to talk a little bit about why the Master of Science Capstone.
Wonderful. Thank you very much, Hitana, and thank you to all the participants for taking the time out of your busy schedules to chat with us and learn a little bit about this exciting new degree. I'll just introduce myself a little bit. I'm, again, Adam Spiro. I'm one of the faculty here in the Department of Biostatistics, and like all the faculty, wear a number of hats in that role. I have an active research program and teach in the graduate program. I'm also chair of the department's curriculum committee, and my role on this call is primarily to talk to you as the director of the new Master of Science Capstone degree that our department is very excited to offer. And for a little bit of historical perspective, I think as many of you may know, we have for a number of decades offered a very successful PhD program and also a thesis-based or a little bit more research-oriented master's degree, and we're continuing to offer both of those degrees. And but what we've noticed over the last few years is that there's also a significant group of students who are interested in getting the kind of training in biostatistics that we offer, and also would like to do it in a little bit more efficient way and know that they're interested in going onto the job market as opposed to focusing on research immediately after graduation. And that's really the genesis of this new degree program. So it is, we call it an accelerated program. That just really means that it's a little bit, it has a distinct timeline that's designed to get you the degree in precisely 18 months, as opposed to the more open-ended degrees like the thesis-based master's or PhD degree. We also work in a very systematic way to prepare you for specific career paths in health-related fields or other data-driven fields. And part of that is that pretty early on in the curriculum, you'll have the opportunity to choose a specialization either in data science, statistical genetics, or modeling and methods. And what I'm going to do for the next few minutes is tell you a little bit about the curriculum in this program and the places where there are core courses, and also the places where you'll take courses and do projects that are more focused on your area of specialization. And as well, you'll note, especially as we start to talk about the Capstone project, and that's a more practical project taking the place of the research-based thesis that we're going to put a lot of emphasis on connecting you with area statisticians and other research professionals. So thinking about the curriculum for the capstone degree, and really this applies to all of our graduate degrees, there are three main aspects of biostatistics that we want to teach. We want to teach the theory. That's really the sort of mathematical basis for statistical methods. We want to actually teach the methods, which are things like regression models or prediction models or the like, and I'll mention a little bit more about that as we go. And we also pay a lot of attention to applications. So what it means to bring to bear the theory and methods that we teach you to solve real-world problems in an impactful way. And in the MS Capstone program, we're going to do that through three parts of the curriculum. There are core courses that everybody enrolled in the degree will take. There are pathway-specific courses, which are sort of like electives, except that they're a little bit more defined based on your chosen pathway in data science, stat gen, or modeling and methods. And then there's the Capstone project, which is a major focus in the second year, and that's where you really tie all of the theory and methods together in an applied project, also working with other students and with faculty and area professionals. And there is a qualifying exam which primarily focuses on theory, and that will be at the conclusion of year one. So if you look at this in tabular form, what we're showing here is the timeline for how you progress through the capstone degree. And what you'll see at first glance is it's really a 1.5-year program. It's autumn, winter, and spring quarters of the first year. So we are on a quarter system here at UW. That means 3 10-week terms. So you'll be taking courses throughout the first year. And the qualifying exam happens at the end of the first year or just at the beginning of summer. And then participation in summer activities is optional. But then the core part of the program resumes the following autumn and concludes at the end of winter quarter, which is early spring. And so the basic plan is that in the first 2 quarters, you'll be spending all of your time taking core courses. So those are prescribed courses that everybody enrolled in the program takes. By spring quarter, you'll have chosen which pathway to specialize in. And so you'll continue taking some core courses, but also be taking some pathway-specific courses. And then in year 2, you'll be taking the remainder of the pathway-specific courses and working on the capstone project. And then again, graduating and finding what we expect to be interesting and gainful employment in the spring quarter. So breaking that down a little bit, in year 1, in the first 2 quarters, you'll be spending all of your time taking core courses, which really span these domains that I mentioned of theory, methods, and applications. So in autumn and winter, there's a 2-quarter sequence in statistical theory for biometry, which is really the foundations of statistical theory, where we'll be covering sort of probability theory as needed for statistics, transformations of variables, sufficient statistics, classical estimation theory, getting into some more advanced topics like semi-parametric and distribution-free estimation theory, and we'll lay the theoretical foundations for developing hypothesis tests and calculating confidence intervals and p-values and the like, which are the ideas that are really important in developing practical statistical methods. In parallel to that, you'll be taking the Biostatistics 1 and Biostatistics 2 sequence, which is a 2-quarter sequence in statistical methods. And the point of that course is to show you how the theoretical ideas that we're developing in the theory course can be used to analyze actual data by first, of course, as always, doing appropriate descriptive statistics, developing regression models, developing prediction models, a little bit of discussion of supervised and unsupervised learning, and interpreting the results of those models, deriving p-values and confidence intervals and being able to interpret them correctly in terms of what the data are telling us and how they relate to the theoretical ideas from the theory course. In the autumn quarter, so the first quarter, you'll also be taking a new course that we've developed specifically for the Capstone degree, which is the Foundations of Public Health for Biostatistics. And this is a course where we'll be giving you a broad overview of the sorts of things that public health as a field thinks about, really, where we tend to be applying our work. So how does biostatistics play into making the population healthy, both from a policy point of view and helping to design behavioral and psychological interventions, thinking about environmental factors that might impact health. And we'll sort of think about all of those topics, both from a public health perspective, so from what people in a department of health or government agency are doing and how they can use the results of biostatistical analyses. So really trying to close the circle and show and help to see how the theory and methods can be brought to bear in impactful ways. In the winter quarter, we'll also be offering a new course specifically focused on writing and presentation and other professional skills, which are important in collaborative relationships. In the spring quarter, there are also continue to be two core courses. There's a computational skills course, so that's where we will help you to start to get into more advanced statistical programming in R and Python and the like, and also a course in data analysis, which will involve case studies in the application of statistical methods to real data sets and focusing on what we can learn and writing reports that will be valuable in applied settings. And so what I want to do now is briefly talk about the pathway-specific courses, depending on which of the pathways you choose. So one pathway that we expect to be very popular is the data science pathway. And so that's really focused on applying statistical methods especially to larger data sets that tend to arise in public health and other high throughput data fields. And so in the spring quarter of the first year, in addition to the computational skills and data analysis course, you'll be choosing two from this list of three courses, one in nonparametric regression and classification, one in the design of medical studies, which is a really neat opportunity to, in a hands-on way, essentially design a clinical trial, and a third course in longitudinal and multi-level data analysis. So that's learning regression methods that can be used for repeated measures data or correlated data. And so you get to pick two out of those three courses. And then as we move into the second year, in the autumn quarter, there's a course in biomedical data science, and that's really a data-focused course with a little bit of discussion of statistical methods, but it's more about how do we really deal with the kinds of large data sets that are becoming prevalent in so many areas. And in addition, of course, on advanced methods for regression with categorical data, in particular logistic regression and relative risk regression and topics like that. And then in the winter quarter, the two courses in the data science pathway are one on more advanced machine learning methods with an emphasis on applications to biomedical and public health big data, and then also regression methods for survival data, and that includes the Cox proportional hazard model and accelerated failure and related topics. So the second pathway that we also are very excited to offer is in statistical genetics. And so here you'll have the opportunity to specialize in methods that allow us to learn about the genetic basis for disease and ideally the genetic basis for wellness. in the spring quarter of the first year, everybody in this pathway will be taking a course in classical Mendelian genetics. And then you'll also have a choice between a course in non-parametric regression or longitudinal and multi-level data analysis, both of which were also part of the data science pathway. In the second year, there will be a course in the autumn in quantitative genetics, and then also a course in advanced regression methods. So that's learning a little bit more about the deeper way to understand regression methods. And in the winter quarter, we'll have courses in computational molecular biology, and then you'll also have an opportunity to learn about machine learning methods for big public health data sets, which are becoming increasingly important in statistical applications. And then also in that second year, you'll be taking part in the statistical genetics seminar, which is fairly widely attended by both faculty and students across our department and the Department of Statistics with research interests in statistical genetics. And then the third pathway that we're offering, we're calling modeling and methods, and this is a little bit more of a mathematically oriented pathway. It still will prepare you for exciting job opportunities, but putting a little bit more emphasis on mathematical modeling. And so in the spring quarter of the first year, you would be taking a course in non-parametric regression, and then also a course in mathematical measure theory, which provides the firm mathematical basis for some of the courses in the second year. And in the second year, there would be a 2-quarter sequence in advanced regression methods, the first for independent data and the second for dependent data. And that's a course sequence that's shared with the Biostatistics and Statistics Department PhD programs. And then also a 2-quarter sequence in stochastic modeling offered by the Department of Statistics. And finally, all of the students enrolled in this pathway will take part in the Biostatistics research seminar in the second year to really see the cutting edge methods that people are developing from a more math perspective. Okay, so that's the coursework component of this degree. The other major part of the educational experience here is the Capstone project, and this again is a more applied project that's taking the place of the thesis in a traditional thesis-based master's degree. And the Capstone project is something that you'll be working on over the course of autumn and winter quarters in the second year. So it's formally offered as 2 courses. The first course we call project preparation, and so that's where you'll really be getting to know the group of students and the professionals and faculty that you'll be working with and planning the project. And then the second quarter is project implementation, where you'll be doing the data analysis and putting together written and oral reports. And also preparing materials for your individual portfolio that you'll be able to share with potential employers at the end of the quarter. And our goal and expectation with the Capstone project is that it's going to bring together all of the elements of being really being an innovative and productive biostatistician or data scientist. So you'll be working on a real-world health data analytics problem that's brought to us by a partner organization in the community that's really a real outstanding problem that they would like some help with, and they'll bring it to the Capstone class and the faculty instructor, and we'll split up into the students up into groups to work on various elements of this problem. And at the end, what each project will involve is significant data analysis, which will include statistical programming and working directly with the non-statistician collaborators, and putting together as a product written and oral reports. And collaterally, as a result of doing this work, you'll get solid and documented experience working as a team and managing projects. And those are skills that we think employers also really look for in a statistician.
So I'll step in here. This is Hitana to talk a little bit about Seattle. I've lived here for 24 years and think it's a marvelous place both to live as well as to study. Seattle is a city on the Puget Sound in the Pacific Northwest of the United States. It's surrounded by water, by mountains and forests. It's Washington State's largest city, and it's home to cutting-edge biomedical, global health, and tech industry work. In fact, Seattle is one of the main commercial and cultural and advanced technology hubs of the West Coast here in the U.S. It is also a major port city for trans-Pacific travel and trade. Seattle truly is a busy and beautiful city. It features exciting work and study opportunities, as well as incredible views and year-round recreational opportunities. And here are some photos just to show you a little bit about both the natural beauty of the place as well as the dynamism of the city itself. This is the UW campus. And as you can see, it's an utterly beautiful campus with wonderful opportunities to study and to work. The Biostatistics department is located in a part of campus that has all of the different health sciences departments, which really facilitates communication and collaboration across different departments and schools. For graduate employment, our alumni will be going into fields such as research, private industry, government, and nonprofits. It's truly a degree that can move between different areas and foci in the field. This page shows the companies. These companies are just a few examples of the companies and organizations where you'll find faculty and alumni. The other thing that you see here is the incredible range of potential employers and collaborators that are present here in Seattle, making it such a great city to do your studies in. For admissions, we're looking for a bachelor's degree or higher. Applicants have degrees in math or statistics, biological sciences, as well as in other fields. We're looking for 30 or more quarter credits in mathematics and statistics, approximately 3 semesters or 4 quarters of calculus, which must include multivariate calculus, 1 course in linear algebra, 1 course in probability theory that is calculus-based. Strong applicants to our program demonstrate solid quantitative skills through coursework and/or GRE quantitative score. The nuts and bolts of admissions is that the applications are due on December 1st. We admit for autumn quarter only, and do begin your application early in order to make it the best statement and the best representation of yourself as possible. This slide gives a sense of the program costs. So tuition as well as fees. You can see it's split up into year 1 and then the 3 quarters, autumn, winter, and spring, and year 2, autumn and winter. And then we've totaled it up for the first year, for the second year, and then what the totals look like for the entire program. We've also broken it down a little bit so you can get a sense of where those totals are coming from. And we're happy to answer questions you may have about this. Also nuts and bolts about living in Seattle. So UW housing 2018-19 rates are listed here on the slide to give you a sense of what kind of opportunities are available on campus. And off campus, shared housing, which is something that a lot of students do as well, giving you a sense of sort of the range of what you're looking for depending on what kind of housing you're interested in. Moving on to funding, most master's students pay out of pocket, so they're from their own savings or loans. A few master's students have jobs, but this is something that the student themselves must search out and find. So we've now moved to the questions part of our program, and we're going to go ahead and look at the questions that have come in during the presentation. And also, this is a great moment if you want to submit some questions that we can discuss and answer. And like I said, if we don't get to all the questions, we will be following up after the presentation has been made. So I'm seeing right now that there are no questions, but I do want to give people a chance to take a few minutes to be able to talk about, or to think about what they want to ask, or what about the presentation that we've made might be more clear. So here I see some questions coming in. Thank you. The first one is, would you elaborate on admission criteria, especially for students who are coming from fields other than math and stat, such as biological sciences? And then this question goes on to say, students who have passed the prerequisites stated on the department website as non-degree students. So we're going to break this up into two questions. The first one is admission criteria, especially from students coming from fields other than math and stat. I'll answer a little bit, and then we'll pass it over to Adam to add to that answer. So we have many students who come into our program who come from the biological sciences. We see this as something that is a valuable training and is a valuable part of biostatistics. Adam, did you want to add anything to this?
No, I think I'd really, thank you, Hitana, and thank you for the question. I'd really just echo what you said. We have always actually really been excited about having strong students join our academic programs coming from what seem to be non-traditional backgrounds for a statistician, the biological sciences, behavioral sciences. We find that some of our best students at both the master's and doctoral level are those who started out with a more applied interest. Yes, the demands in terms of mathematical background are there, and we do need you to have met them and really shown excellence in terms of the mathematical sciences. But coming from a more applied background is viewed as an asset, as long as the mathematical strength is also there.
Thank you, Adam. I see the second part of that question talks about having met the prerequisites on the department website as a non-degree student, and that's perfectly fine. We look at transcripts, coming from people who are not seeking a degree. What we're interested in is, do you know the material? Have you received a grade? And can we look at a transcript for that? Question number 2 here is it ensured that this program will be accepting students for this year? And the answer is yes. Absolutely, we will be accepting students for this year. We look forward to launching the program, and we certainly look forward to seeing your application. Let's see, I see another question. Thank you, this is great. What are the career services and its facilities for students? This is something that I especially appreciate about the University of Washington. It has a recently renamed Career and Internship Center, recognizing the importance of internships in a student building their portfolio, building their experience, and moving into the job field. And so that is the first point of contact. They have extensive resources that are both online and in person. Students can actually schedule interviews with counselors and advisors online, and they can do mock interviews. There's resume review. There's how to build an online presence, professional presence. So there's just an extensive range of resources and opportunities to develop your career as you are studying, as you are a student. And we're going to leave this open just a little bit longer to see if anybody else has questions. Okay, it looks like that's it for the questions. We really appreciate you taking this time to learn about our program and learn about the University of Washington as well as Seattle. If you do have additional questions that you think of after this webinar, please do be in touch. We would be more than happy to talk to you more about any aspect of this presentation or other aspects of graduate school, UW, or living in this region. Again, thank you very much, and thank you to Professor Adam Spiro for presenting today. Thank you.